Section 6.3 discusses exponential probability. Just to give you a quick overview, we talked about normal, now we're talking about exponential. And exponential is another continuous distribution. It's commonly used to measure the time between events, so maybe the time between customer arrivals or the time between failures in a business process. So time, we know, is continuous. Here is the density function, which we won't really be using. So we're going to skip that and look at what the shape of an exponential probability distribution looks like. As you can see, it is skewed to the right. And it's definitely not symmetrical. The shape is completely described by one parameter, and that parameter is lambda. The values for an exponential random variable can never be negative. So if you see the three different lines, the blue line has the highest lambda, and the mean is 0.33. Then for the green line, lambda is 2. And then for the red line, lambda is 1. So if we're trying to find the probability, it is cumulative. So when you're finding the probability and you use this formula, it is going to be less than or equal to the value that you plug in for A, which is any number of interest. You're going to do 1 minus E, which we're going to talk about E. It's a value that is 2.71828 raised to the negative A times lambda. Okay, the formula for the standard deviation, the standard deviation and the mean are the same. They're both equal to 1 over lambda. So let's look at our first problem here. We're looking for, all these are less than or equal to, so I'm just going to work the first one, which is 7. So I'm going to clear this and copy our formula over. In this problem, the mean is equal to 5 minutes per customer, and we want to know the probability of X being less than or equal to 7. So we're going to plug in to our formula here, 1 minus E to the negative, and I guess I'm used to using X, but it's A, to the negative 7. And then I'm going to erase this real quick. So to get the mean number of occurrences, you're going to plug in 1 over the mean here. So 1 over 5. So we're going to do 1 minus 2.71828 to the negative 7/5 power. And we're going to plug that into the calculator and see what we get. And you can even, if you feel like, if you raise that to the negative 7/5 power in your calculator, you would have to put parentheses around the negative 7/5. So if you want to, you can change it to the negative 1.4. And once you do that, you will get 0.7534. So that is how you find the probability of a value that is less than or equal to A. Now, if it's greater than, you're going to use the complement rule. So here, the mean is 8, and we want to know the probability that X is greater than 11. So the mean is 8, and we want to know the probability that X, or A, is greater than or equal to 11. So, or greater than 11. So it has to be greater than 11. So the complement to a value being greater than 11 would be, that means we would want it to be for 12 and up. But this is also, we have to keep in mind that this is continuous. So we're going to find the probability that x, the complement would be, it could be 11 or less. So our formula is 1 minus e, which is 2.71828 raised to the negative 11 power times 1 over 8, which would be a negative 11/8. So if we put that in our calculator, that's going to give you 7.7472. So that to find the complement to that, which is what we need, we're going to do 1 minus 0.7472. And so the probability that x is greater than 11 would be 0.2528. Okay? And let's look at what you do when you're looking for in between 8 and 12. So you're going to plug this into the formula for 12, just like we've been doing, and you're going to plug it into the formula for 8 and get those two probabilities, and then you're going to subtract the larger one minus the smaller one. We've done this before with normal. We're just using a different formula to get those probabilities.